All right, so section 3.4 is meant to be covered in three classes. It's kind of a dense topic. The book, you could kind of do what's in the book in 2 classes, but I'm going to add a third one because I think it's worth doing. The branch of mathematics that we're dealing with is called combinatorics. It's a fancy way of saying counting. If you're wondering when this comes in handy in real life, many examples. I could just give you one. Data security, keeping passwords safe. You can Google this site, but it's something like, is my password safe or secure? And you can see like how long would it take somebody to guess your password. The idea is that you want to have as many different combinations of passwords so that somebody trying to hack into it wouldn't be able to, because there's so many different options. So if you had a password with, let's say, only 2 options and they could only be letters, there's 26 letters, so that would be a pretty small number of possibilities. But if you had 3 options here and they could be letters or numbers, well, now you have 36, the 10 digits time and then the extra 26 letters. That's a much bigger number than that right there. So that's one of the examples that's used in real life. All right, so the first thing I want to mention is something called a permutation. Okay, permutation means that the position that you are putting things in order matters. Okay, so this won't be as clear until we do an example, which we will do in just a sec. But when you're dealing with permutations, or most of the things in this chapter, you're going to be seeing this symbol a lot. The number with a little exclamation after it, and you can see what that looks like here. It's called a factorial. 4 factorial or 4 exclamation means you multiply 4 by all the numbers that are less than it. So 4 times 3 times 2 times 1. 3 factorial means 3 times 2 times 1. Okay, 1 factorial is just 1. So you can find this on the calculator if you have a TI-80 something, go to math, and then it should say PRB, and I don't have it in front of me, but I think it's number 5. It'll just have an exclamation point right there. Alright, so let's do some examples with permutations. So I don't know how many people are familiar with Sudoku. It's a popular puzzle that originated in Japan. You try to fill in the rows and columns so that the numbers 1 through 9 all appear only once in each row, once in each column, and then once in each one of these 3x3 boxes. It's kind of fun and kind of addicting, so if you don't want to become addicted, don't take it up. Okay, so it says how many different ways can you fill in just the first row? The first row. So the first row consists of 4, 5, 6, 7, 8, 9 possibilities. How many digits could go in that first slot right there? And the answer is there are 9 digits. The rules are you can do anything from 1 to 9. How many things could go in the second row? We can't say 9 because remember the rules for Sudoku is you can only use each digit once. So we had 9 options the first one. Now we only have 8 options the second time. How about the third? We could do 7. The next one we could do 6, and you can see we're going to make all the way down to 1. So what's a faster way of saying 9 times 8 times 7 times 6 all the way down? The answer is 9 factorial. So you can put that in the calculator. Again, hit the math button at the top of your TI-80 something. PRB means probability. And then you can access the exclamation. I believe, I don't have a calculator off the top of my head, but if I remember correctly, I think it is something like that. I think 9 factorial is... and I could be wrong, so double check me, but 362,880, so that's pretty extraordinary. That means you have a very low chance of randomly guessing because there's 362,000 ways that you could fill in just the first row of a Sudoku puzzle, which is pretty extraordinary.